And now it's my pleasure to announce Rob Painter from Trimble Buildings.
Good morning. I'd like you to take a look at this building. It's a beautiful building. It's a striking design. It's here in Las Vegas. It's the Harmon Hotel. It's meant to be the centerpiece of the big city center complex just down the strip. There's one problem with this building, though. This building will be torn down before it ever opens its door. In 2008, it was discovered that the structural steel reinforcements had been improperly placed on 15 floors of the building, and then later found that subcontractors had falsified inspection reports. Litigation ensued, and for the last 6 years, this building has served no useful purpose other than that of being a billboard. This is a $279 million mistake. If you get outside this week and take a field trip, you'll see that the building's being torn down floor by floor. They'll spend another $11 million tearing this building down. That's one example here in Las Vegas. Now, if we step back and take a global view, we know that this isn't the only place where this is happening. The vertical construction industry is a $3.5 trillion a year industry. We know that 90% of projects are late, 40% are over budget. The economic implications of this waste and inefficiency are staggering. It goes to the core of our economy, and this is happening year after year after year. There's also social implications. We know that billions of people will move into cities in the coming decades, and these people are going to need to live somewhere. To tackle these problems, we have to build and operate better buildings. At Trimble, we think this is a problem we're solving. Now, to solve a problem, you need to understand the root causes of the problem. And the research tells us that it comes down to three things: ineffective communication, planning, and collaboration. With that as context, Trimble's strategy to transform the work of buildings is rooted in three fundamental ways. First, it begins with life cycle. And for us, that means being present from the ideation to the occupation of a building, using a constructible model as the basis of workflow, and finally doing so in an open and collaborative environment. I'd like to talk about each one of these now, one by one. And let's start with life cycle. Recently, Los Angeles Airport built a new international terminal, and our technologies were used throughout the life cycle of the project. So to give you an example, this is a Trimble model. It was used at the beginning of the project. Our technology was used throughout the construction of the building of the airport. And finally, this technology will live into the ongoing operations of this building to continue to maximize the performance of this asset for the rest of its life. So that's what we mean by life cycle, end to end. And we're really proud to say that there's nobody in the industry that can match our breadth of solutions. Next, let's talk about the constructible model in the world of buildings. Roz talked about it in the world of heavy civil. We'll talk about it now in the world of buildings. And so we're bringing in the geospatial and the heavy civil content, and now we can bring in a building into that content. And I'm not just talking about a pretty picture here. This is highly geometrically accurate building design. It's the architect and the owner who are working together at the beginning of the project to conceive this. This forms the basis of the constructible model. Now from here, you need to now go do this more detailed structural analysis. And I'll use an example in Paris. It's a Frank Gehry designed Foundation Louis Vuitton museum. It actually just opened up. But here in the construction phase, hopefully you can see a little bit of the steel. That's a Trimble model that was underneath that design. And to give you a sense of the level of detail we're talking about in these designs, this goes down all the way to the level of the anchor bolt. So that same model goes from here all the way down to the anchor bolt level of detail. You're planning and you're designing that quality and that efficiency up front in the beginning of this project. And what you effectively have is this merge of the physical and the digital worlds coming together. Now you have to produce the steel on this building. The constructible model now goes into the fabrication and detailing of the beam. And literally, our models are driving the machines there that are drilling the holes. So I hope you're getting a sense that this isn't just a pretty picture. The same thing's happening in the fabrication of the mechanical ductwork. So the plasma cutters are driven by the constructible model. Let's go out to the field now. Now we're in the field, we're on the job site trailer, and we have the structural, the mechanical, the electrical contractors sitting together in a room, working together to coordinate their models, because their models have been done individually. Now they're brought together, they're coordinated, and what you're able to find and what you're able to achieve here through this coordination is these guys are eliminating the waste and the rework and the inefficiency before they ever step out into the building, because they know where the problems are going to happen. Now they're in the building. Everything you see on the screen has to be precisely positioned and laid out. Using Trimble technology and bringing that model out into the field, to give you a sense of the productivity that's happening, is they're going from doing 30 to 40 points a day in the old school methods of layout to 300 to 400 points a day using this technology. So the productivity is game-changing by bringing this model out to the field. We're extending this model even further because it's going into the project management tools, and we're able to intersect dimensions of time and cost on top of that 3D geometry. It's extending the constructible model to manage the labor, the equipment, and the materials on a job site. Finally, the building's been completed, and the model is now handed over to the owner or the occupier of that building. We call it an as-built model now. This model will continue out to the rest of the life of the building. It's important to understand because upwards of 80% of the cost of a building through its lifetime happens now from this operational phase on. And this model will then form the basis to manage the facilities. It can manage a portfolio of real estate. It can manage the space within this building. It's managing the maintenance of the building. It's managing the eventual renovation of the building because now you have an as-built model to work off of. So to summarize this constructible model, I hope you can see that the information richness and power and value grows throughout the life cycle of this building. And this model is being delivered and built and delivered by domain experts, another thing which we think cannot be matched in this industry. Now finally, the last part of the solutions approach I want to talk about is open collaboration. Our industry is complex. Our industry is fragmented. And so our strategy is rooted in the principle of trying to get people out of their silos and working together more holistically on projects. It's about bringing all the various applications that are used throughout a building and connecting those together. It's about connecting that office and the field. We're really excited this week to be launching our solution for open collaboration, which we call Trimble Connect. And for all you Trimble people in the audience, show them how excited you are about Trimble Connect. Let me hear you. We hope to make a lot of noise about Trimble Connect this week. And what you'll find is that Trimble Connect is a cloud-based solution that's providing a workspace for designers, builders, operators of buildings to come together and share their data throughout the life cycle of a building, and to be able to do so anytime, anywhere. So, to summarize our strategy, we're talking about providing an open and collaborative environment upon which to work with the constructible model as the basis of workflow throughout the life of a building. In conclusion, I'd like to talk about an example of customer success. Earlier we talked about the Los Angeles airport, and I want to share with you the story of Corman Construction, who used Trimble technology throughout this project. They shared some of the following results with us. They were able to reduce the time on the project, so the project duration went down by 10%. They achieved a reduction in the cost of field layout of 50%, and they also increased the accuracy and were able to reduce the rework on the building by 80%. This is real power, this is real value, and the benefits of this accrue both to Corman as well as to the owner of the building. So to learn how you can achieve results like this for yourself and for your customers, we invite you to come join us this week. I'm now going to turn it over to Pete Large to introduce our speaker for the day. Thank you very much.